As we go on to Chapter 2 now, we will be continuing our vocabulary building and review of basic skills needed to do the more complex algebra we'll be getting later in this chapter and then throughout the remaining chapters. So we want to identify what is a term, what is a like term, and unlike terms. Then we'll work on skills in combining like terms. We'll use the distributive property to remove parentheses. And then we're going to practice again converting English word phrases into algebraic expressions. This will lead us toward problem solving later in this chapter. We'll give you a little background with this here. Again, reading the textbook gives you lots of information and background on what we're going to be reviewing here briefly. And here is an algebraic expression. Now, as we look at what is a term, well, pretty generally, a term is separated by either a positive or a negative sign. So here we have 4 terms. Now, each term has a specific part to it. For instance, as we look at this first term here, there is a variable, which is the base, that is raised to a particular power, that is the exponent. Now, along with the variable, the letter, there's a number in front. This number is called the numerical coefficient. And if there's no sign, then a positive is included with the 3. Now, as we look at this term, its variable is x. Now, there is no exponent written there, but when there isn't one written, we assume there is a 1 there. And its numerical coefficient is 2. And then so on and so forth. And then here, our term is a negative 4. There is no variable associated with it. So, with that in mind, let's take a look at example 1. Identify the numerical coefficient. Well, it's not the variable part, it's what's in front. So that would be a 9. This would be a negative 3. Now, when you have something like this, you might say, well, there isn't any. Well, again, if there isn't a number in front of the letter, there is a 1 there. So our numerical coefficient here is a negative 1. And then here it's going to be a 2.7. Now, as we look at this example I put up here, we see there are 4 different terms. Are any considered a like term? And by definition, a like term has to have exactly the same variable. So 2x and 3x, since they have exactly the same variable, are considered like terms. This one and this one would not be. So we only have these two that are like terms in this expression. Now they're asking us to determine whether the term is like or unlike. Well, here we have a variable of x, a variable of x, so these are like terms. Now here we have x to the first power, x to the second power. So even though they both have an x and a y, these are not like terms. Now here, this has an a and a b, and this has an a and a b. Now even though they're switched around, they are considered like terms. Because I could rewrite this using the commutative principle of multiplication like so. Now here we see x to the third. There is x to the third. Y to the first, y to the first. Z to the second, z to the third. So they're not like terms. Okay, now here they're asking us to simplify each expression by combining like terms. Now up here, if I wanted to combine the like terms, I have two x's and three x's. So all I'm going to deal with when I combine like terms are the numerical coefficients. So this is a plus 2 and a plus 3. So now I have 5 x's here. I have combined the like terms. And here I have a 7x minus 2x. So that's going to give me 5x, and then I bring in my plus 4. Now, one of the things you want to do is to identify your like terms. So this is a y, and this is a y. And remember, there's a 1 in front of that. And if you want to put that there, that's okay. So we have a negative 9 and a positive 1 will give us a negative 8y. And then I have a 2 and a 6 is 8. Minus 1 is 7. Minus 7 is going to be 0. So when I simplified this, it just becomes this. All of these add up to something that will subtract out. So I could have put the negative 1 and the negative 7 together, got a negative 8. 2 and 6 is a positive 8. The 8's cancel out. Now here, this is x to the 5th. X to the 5th, these are like terms. Now, one of the techniques I will stress a little later is when you're combining like terms, sometimes it's good to put them vertically. So here I have a 1.6 x to the 5th, and this is a like term, so I'm going to put it right underneath. So actually they're asking me to subtract this, so I get a 1.3 x to the 5th, and then the other part of that answer is this, that I can just write after it. I don't have any room, so I'm going to write it in front here. Now usually when you write terms, you put them in some sort of order, that the highest variable would kind of go first. So I'm assuming they have this, answer this, and then plus that. Okay, let's raise it up a little bit. Oh, my wife was asking me something. Let's continue though. Simplify each expression. Use the distributive property to remove parentheses. Okay, as we start to build on what we had in chapter 1. So we distribute that and get 3x. Distribute that and get 18. Now here's an interesting thing that we're going to use frequently. When there's a negative sign in front of a parenthesis, all we do is remove the parenthesis and reverse all of the inside signs. So we're going to remove the parenthesis here, and this will become a 5m, a positive. This was positive, so it now will become a negative. This was negative, so it will now become a positive. So a very important skill, when there is a negative sign in front of the parenthesis, you just remove the parenthesis, change each of the signs. And here we can do some cross canceling. 3 goes into 6 twice, so this becomes 2x. Watching our signs, a positive times a negative gives you a negative. 3 will go into 9 3 times. So we have removed parentheses. That's a skill you'll be working on. Now here they want us to remove the parenthesis and then simplify by combining like terms. So let's put that up here and clear this up a little bit. So 2x times 14 will be 28x. 14 times 6 is 84. And we have a negative 4 here. So we don't have any variables that are like terms, but these are like terms. So 28x plus 80. So this will be 10a, a minus 5. And now we're going to distribute the negative 2 to the a, gives us a negative 2a. A negative times a negative gives us a positive. 2 times 3 is 6. So we now have a 10a minus 2a is 8a. And we have a negative 5 and a positive 6 gives us a positive 1. In the letter F, 2, let me see here, 2x times 3 will be 6x. 3 times a negative 5 is a negative 15. Now here we have a case of a negative in front of a parenthesis. So we're going to remove the parenthesis, change both of those signs. It was a plus, but we got to change it though. Got to follow what I say. So this becomes a negative x and a negative 7. Now we combine like terms. That will give us 5x. A negative and a negative gives us a negative 22. Now I check those and they all check. And again, the answers are down below here. All right, continuing. Write each phrase as an algebraic expression. Simplify if possible. This is very important. I've seen some people in math lab, when they took their test, they did this first part correctly, but then they didn't simplify. Again, you have to answer the question that's asked. Here they want us to put it into a phrase and then simplify. So, let's take a look at number 1 here. Add this to this. So, again, as you set it up, you might do it this way. You might say 6y minus 9. You're going to add this. So just put it there. Negative 4y plus 3. And what I've done, and I strongly recommend this, is to put them in like-term vertical columns. So this is going to become a negative 6, and this becomes a 2y. And, there's no more simplifying needed. Now this is a little tricky. It's saying from this, so I'm going to write this, 3x plus 7. Super important. What do they want us to do with this? In a sense, they want us to subtract it. So, what do I do to each of these terms if they want us to subtract it? Well, we're going to change the signs. Remember, this is subtract minus this. So this will become a negative 2x. And this, again, we're subtracting. We have to reverse the sign. Becomes a positive 1. Notice, lots of people can get messed up on this. You'll be doing your practice. And again, the rule is if you are subtracting something, change its signs and then just add them, because you've now indicated you're going to subtract. So this becomes an 8, and this is just an x. Now you might think you put a 1 there, but we don't do it by convention. Okay, triple a number. Triple a number. Well, we don't know what the number is, so we're going to call it x. Now, if you triple that number, it's multiplying it by 3. And then you're going to decrease it by 6. So we're starting off with some very easy algebraic expressions. 6 times. Now this again is critical. When it says the word sum, how do we indicate this sum? And the answer is you put it in a parenthesis, indicating it was added together, a number and 2. Now, if you left it this way, MathLab would count it wrong. And you might say, why? Well, because you didn't simplify. But I see down below they are leaving it that way. Well, all right. I would say that MathLab, since they're saying simplify, is to get rid of the parentheses. This would have been 6x plus 12. Now, this is where the teacher often gets involved when you're taking a test and you have read it and you wrote this, which is what I think it should be, and they wanted this and they're counting it wrong. Well, that's when we as teachers, not only myself, but other teachers in math lab, when you take a test and you have the work on your blue sheets, you show that, oh, the work was here, or I had that, but I thought they meant this. I can give you full credit for this, okay? Because this is what they wanted, but simplified, it's this. Getting rid of parentheses is simplifying. Often it would be like terms. If you had 2x plus 2 times x plus 1, let's say they asked that. Well, that would be 2x plus 2x plus 2 as you distribute, and then the answer they would want is 4x plus 2. And again, I may have given some credit for that, but again, every example, could be interpreted maybe a little bit different, and that's why write your work, show it so we can give you partial credit, or in some cases, full credit. I had a student recently, they had on their paper 2x squared plus 2x plus 1, let's say. And then that was on their paper. But then they put 2x squared plus 2a plus 1 into the computer. Well, that's just a typo, because they had this on their paper. Gave them full credit. They earned an extra point. Okay, well, let's start. We've started chapter 2. We'll continue.